let's look at the classification of alcohol. Here I have the generic alcohol with the R representing the alkyl group and the OH representing the hydroxyl group. So if I have a carbon bonded to an OH, and that carbon is bonded to one other carbon in this alkyl group here, that is said to be a primary alcohol. This carbon over here is bonded to two carbons in those two alkyl groups, so it is therefore a secondary alcohol. And lastly, this carbon over here on is bonded to three other carbons, so therefore it is said to be a tertiary alcohol. And now, let's move on to the nomenclature of alcohols. The chain is always numbered beginning at the carbon to which the hydroxyl group is attached. Substitutive names of alcohols are developed by identifying the longest continuous chain that bears the hydroxyl group and replacing the E ending of the corresponding alkane by the suffix OL. The position of the hydroxyl group is indicated by number, choosing the sequence that assigns the lower locant to the carbon that bears the hydroxyl group. First, find the longest carbon chain. It's a 5-carbon chain which gives us pentane. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So therefore, this carbon would get number 1. And this carbon would get number 2 and so on. Since there is a hydroxyl group present which is the OH, the letter E in the name of the alkyl group must be replaced with OL. So this alcohol is called pentan-2-ol since the OH is attached to the second carbon. Now, let's have a more difficult one. A substituent is present in this molecule which is methyl. As said, the OH must be given the lowest number possible. 1, 2, 3. There are 3 carbons which give us an alkyl group of propane. The substituent is attached to the second carbon, thus the name of this molecule is 2-methyl-propan-1-ol. 1, 2, 3, 4, 5, 6. Since it has 6 carbons, it will have a prefix of hexane. Since it has a double bond present and is in locant 3, it will then be hex 3N. The hydroxyl group is attached to the second carbon, thus the final name of this molecule is hex 3N-2-ol. Let's now discuss the common reactions of alcohols. Dehydration. When heated with strong acids catalysts, most commonly H2SO4 and H3PO4, alcohols typically undergo elimination reactions to generate an alkene and water. Also known as dehydration since it involves the removal of a molecule of water. When dehydration occurs, a molecule of water is removed from the structure of an alcohol and the agent that acts as a catalyst is H2SO4 or sulfuric acid. The alcohol is then converted to an alkene. Now, let's move forward to the next reaction of alcohols that we will discuss. Oxidation. A process in which a chemical substance changes because of the addition of oxygen. This is the structure of an alcohol, and this O in the parentheses symbolizes the oxidizing agent, which could be something like KNO3 or potassium nitrate. These oxidizing agents have the ability to remove hydrogens from the structure. One from OH and one from the carbon that the OH is attached to. The end products will be water and the other would be, to maintain a complete octet for the carbon, a carbon double bonded with the oxygen atom.
Ethers have the general formula ROR, where R and R prime represent the alkyl groups and the O represents an ether group, which is an oxygen atom. There are two ways of naming ethers, the common way and the IUPAC way. We will first start with the common name. Here is an example of an ethyl group, and this over here is also an ethyl group. Since there are two ethyl groups present, this will be diethyl ether. And this ether over here tells us that there is an oxygen atom between the two ethyl groups. And now, I'll show you how ethers are named based on IUPAC. First, we'll look for the longest carbon chain. Since both have the same number of carbons, we can pick any of the two. Here is an alkyl group of ethane. And here we have an alkoxy group. Thus, it will have a suffix of oxy because of the presence of an oxygen atom. And since there are two carbons, this will be named as ethoxy. And since the alkoxy group is attached to the first carbon, this molecule will be named as 1-ethoxyethane. Now let's have a more difficult one. There are two carbons in this alkyl group, which gives us ethyl. And one carbon over here, which gives us methyl. The substituents must be arranged alphabetically. Thus, it will be named as ethyl methyl ether. Now, let's name it with a IUPAC naming system. First, look for the longest carbon chain. There are two carbon atoms in this group, thus it will be ethane. Here is the alkoxy group, and since only one carbon is attached, it will be called as methoxy. And since the alkoxy group is attached to the first carbon, it will then be named as 1-methoxyethane. And for the last example, as we can see in this molecule, there is methyl and the presence of a cyclic structure. And since there are three carbons in this cyclic molecule, this is called as cyclopropane. And since the alkyl groups attached to the ethoxy group must be arranged alphabetically, its common name must be cyclopropyl methyl ether. The cyclic structure is prioritized, which is the cyclopropane. And the alkoxy group has only one carbon, thus it will be methoxy. 1-methoxycyclopropane.